Hi, I welcome you all for another beautiful presentation on signals and system subject. Today, I would like to present the signals and systems concepts. So, today basically we will see what is a signal and then what is a system, what are the various classifications of signals, as well as what are the various classifications of systems, and brief overview of signal systems we can see in today's presentation. Yes, in this presentation, I would like to discuss about the signals and systems subject. This is one of the another beautiful, very interesting subject, especially for electronics and communication discipline graduates, as well as electronics and instrumentation graduates, and probably the electrical and electronics engineering graduates also have this particular subject. This is very interesting, very beautiful subject, and this is one of the topmost important subject those who are preparing for gate examination, as well as any other state and central level government examinations. Just I want to do the videos or presentations parallelly on this subject also. We are continuously seeing that control system subjects, whereas I thought that it is good to present this subject also, so that many of you can be benefited. And okay, so in today's presentation, I would like to give you a brief overview of the signals and systems subject. Here I want to under this particular this thing, and our starting module, don't confuse with this. I will give you the instead of lecture 1, lecture 2, lecture 3, which we have seen during our control systems subjects presentations, for this particular signals and systems, I would like to give you SS, means signals and system 01, means lecture number 1, like that I will follow. And please, I request you all to follow the same, and you will get the continuous updated presentations, okay, which is presenting by me through this effective and efficient electronics for excellence program. Clear? So right, so in this, actually, under this particular signals and systems subject, I am going to cover the basic fundamental requirement which normally you all people need under your graduate level. Means normally it covers the basic information of signals. Means that what is a signal, then what are the classifications of signals, how a signal can be defined. These things we will cover in this particular. Similarly, what is a system, okay, how the system can be defined, and what are the types of systems, and what are the properties of systems, how these systems can be used in order to process the signals. Likewise, and then there are many applications of these particular subjects with respect to the signal concern. By the way, in this presentation, I am going to give you very brief introduction today, and then we will see some more very interesting and topics of related to signal systems in subsequent presentations. As a introduction part, just I will give you very simple, very brief, and very easy way of methodology to understand the subject, right? You will enjoy this definitely, as you are enjoying your control system subject. Clear? So What is a signal in this? Basically, normally for any graduate levels, I think probably you will have your unit number 1. Under your unit number 1, you will have the signal. What is a signal? Classification of signals, and then various properties of signals as well as like that. Okay. Today, what I am going to cover is that under our first module of signals and systems, what is a signal? What is a signal? How a signal can be defined? Okay, very interesting definition is that a signal is any physical quantity that conveys some amount of information is called a signal. Clear? Any physical quantity that conveys some amount of information is called a signal. Clear? So normally, what are the examples we can say for signal? Signal is our speech signal. As I am continuously speaking, this is a speech signal. My speech conveys the information. Means what is the information? Means explanation or giving the presentation on this particular topic of the signals and system. I am presenting that. That is the information which is coming in the form of signal. That is the signal. Similarly, say for example, the graph EEG or ECG, electrocardiograph or electroangiograph, if you say in medical, terminology, ECG. So your ECG, heart related things, it will be examined in the form of waveform, nothing but a signal. So by observing that, we can identify the functioning of our heart, how our heart is functioning, how good our heart is, like that. So that is a signal which gives the information about the functioning of heart. That is the example of a signal. Like our mobile communication or satellite communication, like that. Through this communication, what we are observing, what we are getting, some amount of information getting transferred or transmitted. At the same time, some amount of information is received. Means the information is going to travel, it is going to be transmitted, the same information can be received. The information means the content. Clear? Therefore, these are the basic examples of a signal. Therefore, as an academic point of view, you please remember that a signal is nothing but, if anybody asks you, or it is asked in the examination, define a signal, or what is a signal, question mark they will ask. Definitely you should write in inverted commas is that any physical quantity, any physical quantity, any physical quantity that conveys some amount of information, some amount of information, it must contain some information, is called a signal. That is the very beautiful definition of a signal. Clear? This is what a signal. And normally, as far as our subject is concerned, your signal is denoted by either x of t or sometimes y of t, or else with any other letter. This can be represented x of t, y of t, or anything else, no problem. Right? You can identify, you can denote by any number, any letter, no problem. So if you see that here x is your signal, whereas the small t, this small t is nothing but our signal depends on time. Our signal depends on time. Similarly here also, this y is a signal and it is a function of time. Y of t is nothing but y is a function of time, means y depends on time. This small t is called time. It is a time because time is an independent variable. The time is an independent variable. So rather than we have to depend on time, time will not depend on us. In fact, time will not depend on anybody else, because time will stop for you and for me. It will not stop. It will goes on. It will moves on. Therefore, we have to run with time. Clear? So that's why always that is the so therefore x of t is this representation of a signal, or y of t is the representation of a signal. Therefore, small x, small y. Normally, the signal is denoted with a small case letter or small case letter like this: x, small y, small x. Of t means it can be read as x of t, y of t. It depends on time. Okay, then again remember that the time is again classified into two ways. There are two types of time that is to be considered under our signals and systems subject. If you consider the time can be defined or can be categorized into two variants, two categories. One is continuous time. One is continuous time. Second one is the discrete time. Second one is the discrete time. Continuous time is denoted by small t. The continuous time is denoted by small t, whereas the discrete time is denoted by small n. This is the basic difference between continuous time and then discrete time. You must remember this. The continuous time is denoted by the letter t, whereas the discrete time is denoted by small n. What I mean to convey you by giving this information is that the signal, let us say x is the signal, can be defined over a continuous time, or otherwise can also be defined on or in a function of discrete time. Understood? Our signal, whatever the signal you are talking about, or whatever the signal you are considering, that can be function of either continuous time as well as that can be a function of discrete time. If the signal x or small y, if it is depending or if it is a function of continuous time, that is t, then it is called a continuous time signal. Clear? If it depends, so that means that, okay, if the x is function of this t, means this t, then your x of t is called a continuous time signal. Understood? You are getting now, I think. So if you write that signal x of t, then this x of t is called as a continuous time signal. Say for example, if I am considering the discrete time, then you must write x of n. This is the discrete time signal. This is the continuous time signal. Thereby, you easily can identify this. One of the classification of signal. This is what is that? Signal can be classified into further some categories are there that I will explain you slowly little bit afterwards. So right now I think two classifications you already got now. One is continuous time signal, second, and the discrete time signal. Means if the signal is defined over a continuous time interval or over a continuous time period, then that signal is called a continuous time signal. Means it is a continuous, actually your signal is a continuous, there is no gap actually. Say for example, if you consider your sinusoidal signal like this, it is a continuous signal. It is goes on, actually never stops. It starts somewhere, goes up to like that. It is a continuous time signal. Whereas if you consider the discrete time, discrete means it is a random. Discrete means it is a random, or otherwise you can say discrete means it is not a continuous one. It is not a continuous one. It is the opposite of continuous basically. Okay, means that so in discrete time you will not have this kind of continuation in the signal. You will have some certain gaps will be there. Means during some time interval you will have the signal. Means signal is defined for certain intervals and the signal will be zero for certain intervals. Again the signal will be defined. Signal will be given for certain intervals, like that go on. Some gaps will be there. So that kind of signals we are naming it as discrete time signal. Understood? This is discrete time signal. Therefore, this is what about the signal, basically very basic information. I think you are getting this. Clear? Therefore, signal is nothing but physical quantity that conveys some amount of information is called a signal, and the signal is denoted by either x of t or y of t, or sometimes x of n or y of n. X of t, y of t or the representation for continuous time signals, whereas x of n, if you write small n, x of n and y of n, these are the representation for a discrete time signal. Clear? This is the basic definition of a signal. Well, very nice. Then what is the definition of a system? What is the definition of a system? In general, just I will give you the definition, and afterwards slowly I can give you a little bit elaborate information, means types of signals, and then I mean the major part of it. In detail we will see in the next subsequent. Let me finish you about, I want to give you the just a brief overview actually in this presentation. So this is what the basic definition of a signal. And what is the system then? What is a system? How a system can be defined? System, again, if you define the system, system is a physical device. It is a physical quantity. It is, signal is a physical quantity. Whereas if you define the system, it is a physical device. It is a physical device that performs certain operations on input in order to get the corresponding output is called a system. Clear? A system is defined as it is a physical device that performs certain operations on input in order to get the required output is called a system. Therefore, normally that can be, I think, shall I write that? I will write for your better understanding so that many of you can expect from me that to write the definition. Yes, for those, I think it is good to give you so that you will be remember very easily. Clear? Therefore, now I can define a system as, system is nothing but it can be defined as, it is, okay, a system may be defined as a system, you write anyway, no problem. A system may be defined as any physical device. You can write like this, any physical device that can performs certain operations on the applied input in order to get the desired output. Clear? In order to get the desired output is called a system. This is what the perfect definition of a system. It is a perfect definition. Clear? It is a physical device actually that performs certain operations. It performs certain operations. So it can be represented like this. A system may be represented like this. A system may be represented like this. It is very simple actually. System means, I think you are well aware of. This is what a system. This is what a system. This is what a system. This is what your input actually. Let us say I am considering as x of t for your understanding just now. X of t. This is the system basically. It is denoted by or represented like this, and you will get corresponding your output, maybe y of t like that. For time being, assume like this. This is the input actually. X of t is your input basically. Input means signal, input signal. You can write it as input signal. This is what you will get, your output signal. This is what your output signal, or sometimes also called as response. This is what your response basically. Clear? So this is what a general representation, basic representation of a system. So x of t is the input, whereas y of t is the output. Clear? This is what the simple representation of a system basically. Clear? So next is the classifications of signals. What are the classifications of the signals? Okay, and how these signals can be defined, classifications of signals and the definition of signals, that we will see. Similarly, what are the classifications of systems, and then the definitions of systems, and as well as their properties also we can see. So with this brief review, I just finish off this presentation, and this is like a warm-up presentation for you to start the signals and systems subject. It is very interesting. Definitely, you will definitely enjoy. I am sure that. Therefore, in subsequent presentation, continuously I will present the all the topics which will be required for you as far as your academic is concerned, as well as your competitive examination point of view also. Right? With this, I will finish off this presentation. Okay, see you.